Hey, General Math, we're going to finish up 5.1 today with some factoring. First thing we have prime factorization. That's starting with a big number and breaking it down into all the little prime numbers that go into it, that multiply into it, that factor into it. And then how many times those factors go in if they do go in multiple times. So, for example, we have the prime factorization of 18 right here. Well, what multiplies to 18? What prime numbers multiply to 18? We have 2 times 3 times 3 times 3. So I think that's wrong, actually. Extra 3 in there. So we actually have the prime factorization of 18 is 2 times 3 times 3. 2 times 3 is 6. 6 times 3 is 18. Right, there we go. And then the easiest way to do this, so I just did that in my head, but the easiest way to do this and visualize it is to make a factor tree. So for example, the prime factorization of 140. So we have this really big number. We want to break it down into some prime numbers. So what multiplies to 140? Really quick, we have 14 times 10. 14 breaks down into 2 times 7. 10 breaks down into 2 times 5. All these are prime numbers. So we want to write this as 2 times 2 times 5 times 7. But how many 2's do we have? We have 2 2's, so let's write that as 2 squared times 5 times 7. And then two numbers are relatively prime if they have no factors in common except for 1. So let's look at 42 and 55. 42 breaks down into 6 times 7. 7's prime, but 6 can be broken down into 2 times 3. So we have 2 times 3 times 7. These are kind of the branches of the tree. That's where they end. 55 breaks down into 5 times 11. Both of these are prime. So if you look at these numbers across the board, we have 2, 3, and 7, 5, and 11. None of them are the same. So they are relatively prime. And then same thing down here, but we do have a repeat. We have 2 times 3 times 7 and 3 times 17. They both have 3 in common, so they are not relatively prime.